Hello friends, welcome to my channel together with Abhi. In the last video, we discussed about the theoretical aspects of virtual private cloud. In this video, we are going to see the practical implementation or demo related to virtual private cloud. For easy implementation, what I have done is I've created a lab guide. So let me open up the lab guide. This is the lab guide which is going to guide us step by step on what needs to be done for implementing a VPC in AWS. So let's get back to our AWS Management Console. In AWS Management Console, the first thing we have to do is go to Services and look for VPC, which stands for Virtual Private Cloud. It will open up a VPC dashboard, something like this. The first thing to be noted is about the region. VPC is specific to region, so we are working in Mumbai region. Everything that we are going to create is going to be specific to Mumbai region. Now let's open up what has been created by default. So far we have created nothing. Whatever has been provided by AWS by default. So a default VPC has been created. So whenever we were launching any EC2 instance, it was getting launched within a default VPC. 3 subnets. Why 3 subnets? Because we have 3 availability zones within this region, and that is why per availability zone there is 1 subnet. As I mentioned, subnets cannot span across availability zones, but one availability zones can have multiple subnets. So you can see everything is default subnet. Everything has been created by default. The next thing is root table. There is one main root table which has been provided. If any subnet has not been associated with any root table explicitly, it will be directly associated with this root table. So as you can see, subnet associations, all the 3 subnets have been associated to this main root table by default. And the roots it says is one local root which helps you interact or communicate between all the resources of the VPC, and the other is Internet Gateway. Now since Internet Gateway has already been provided, means there is one Internet Gateway which is available by default. So it's time to take a look at the Internet Gateway. So yes, if you click here, within Internet Gateways, you can see there is one Internet Gateway which has been provided to default, and it has been attached to the default VPC, the VPC that we just saw. Other than that, DHCP options is okay. Network ACL, yes, one network ACL has also been provided to you. If you see here, it provides you allow and deny rules. So this network ACL is attached to all the 3 subnets. As you can see, it is written associated with 3 subnets, and inbound rule and outbound rules allow and deny, which is contrary to the way security groups work, which only provides you the allow mechanism. Here you can do both allow and deny, but we will take a look at these differences in the next video. So this is all. Now let's close everything and we will start from scratch in creating a VPC of our own. One thing also to notice is there is a launch VPC wizard, as you can see at the top. Okay, this gives you a quick steps to make VPC, but one-click solutions kind of thing. But this won't allow you something to learn. So best that we start everything from scratch, and then probably you can always make use of them once everything is clear to you. So let's go to VPC, and we will click on your VPCs right here, and we will go and create VPC. Okay, we are going to click on create VPC. Firstly, we are going to give the name as per the lab guide, my VPC. CIDR block again 10.0.0.0/16. So I already covered about this addressing mechanism in the last theoretical video. You can take a look at it. Tenancy, we will keep everything as default. We are not going for IPv6. So as you can see, the VPC has been created with an address space. Important to note, this address cannot be changed later. Now we need to note a default root table and a network ACL has been created. So now if we go for this VPC, a default root table other than the root table which used to exist by default and network ACL that used to exist by default, another root table and network ACL has been created as soon as you create a VPC. Important. Why? Because any subnet which has been created within this VPC is going to get associated automatically to this new default root table. Okay. Next thing we have to do is create subnet and name it my private subnet, assign it IP address space like this, and we have to just see how many IPs are assigned. So we'll go to subnets. We are going to create subnet. Let's name it my private subnet. The VPC we are going to use is the VPC that we have just created, my VPC, and availability zone. We are going to keep them in different availability zones. We will give them the CIDR block from the address space which has been allocated to my VPC. I'm going to use /24. So within that, I'm going to associate somewhere around 251. So again, my private subnet, my public subnet this time, similar mechanism, my VPC, availability zone, another availability zone, and CIDR block this time, a little different, 10.0.0.0/24. So by 24, what I mean is 24, the first 3 bytes are going to get fixed, and I should be associated with 256 minus 5 equal to 251 IP addresses. Next thing, let's create Internet Gateway. One has been already created by default, but we will create another one. Let's name it my Internet Gateway, and I'm going to associate it with the new VPC that I have just created. So in the illustrations in the diagram, you can see what we are creating and what we are doing. So it is in the detached mode right now. Let us attach it to the VPC, and the VPC we are going to use is my VPC. Let's attach it. Now the next statement is create root table and name it my root table. This is important because so far we have just created subnets and we have named them public and private, but they are not essentially public and private unless we make an entry in the route table which associates it to the Internet Gateway. So that is why we need a route table. So create my root table, create it in the VPC that we have just created, my VPC, and this has been created. So the root table has been created. Now the next thing that we need to do, and let's name the main root table which is in my VPC, my main root table, because everything within our VPC which is not associated explicitly to my root table will be associated to my main root table. So diagram something looks like this. Now we are going to create entries in my root table to allow access to the outside world through Internet Gateway. So for the public subnet, we are going to do this. Okay, so it makes it truly a public subnet because it will have a mechanism to communicate to the outside world. But for private subnet, no such entry will be made. So please note the root. This is the local root, and we are going to enable another root for the outside world, which is .0.0.0/0 and through Internet Gateway. So the definition of a public subnet is which is connected to Internet Gateway. The one which is not connected to Internet Gateway is called a private subnet. Now let's add it subnet associations in my root table. So until now it has not been associated. So we are going to associate my subnet, my public subnet, to this root table. And we are not going to associate my private subnet. So that means my private subnet is by default associated to the main root table created by default within this VPC. Okay, so this has been done. My root table has been associated. So the diagram changes a little bit. The associations have been changed. Now, so far my private subnet is associated. The next thing that we have to do, we will get back to our lab guide and see on the next statements, which will tell us about launching EC2 instance. Now we need to create our public and private servers. So the statements are given. We have to create it within my VPC, within my public subnet. So we will go to VPC Dashboard and click on Launch EC2 instances. Let's close everything so we are not confused. Let us look out for free tier only. Anything by default that we can use, anything in free tier. Important to note the network that we are using. We are going to use my VPC, my public subnet. Okay, and within my public subnet, I want to auto assign public IP. Within public subnet, any instances that we are going to launch should have public IPs, so they can be reached by internet. Okay. A storage we do not care about. Let's just add the tag. We will just name it my public server. So let's name it my public server. We will configure the security group now. The security group is important for us because we want this to have access from the outside world. Okay. So as per the lab guide, it says we are going to create a security group, my Linux public security group, and we are going to provide SSH, HTTP, and HTTPS. These three we are going to provide. So let's look out for the protocol HTTP. Port, it automatically takes 80, and for HTTPS 443. It also provides source as IPv6. We can leave it like this or we can remove it because we are just looking at IPv4 as of now. So if you want, you can remove it, but even if you leave it, it is not going to matter much. So let's launch it. We are going to select a key pair. I already have a Linux key pair with me. So I will just acknowledge and we will launch the instances. So let's go and view instances. So instances, while they run, if in case you want to create a key pair of your own, you can create it and you can name it my public Linux key pair. It is in the pending state. It is going to be in the running state very soon. Meanwhile, we will just go to terminal and we will see how we are going to get connected to this machine once it is up and running. So the next thing that we are going to see is within the terminal, we are going to verify if we have an internet connectivity to this machine or not, which has been launched within public subnet. So it is in the running state. The machine has been launched. A security group has been created for it. Network ACL was by default created when we created VPC. Let's try to SSH into this machine. So SSH EC2 user, which is going to be the username for any machine which has been launched as Linux AMI. And we are going to catch the public IP address. Please note a public IP address has been assigned because we enabled auto assign public IP. Otherwise, by default, it would not have been assigned because in the public subnet, we said the default option is disable. So currently, we are able to launch this instance and we are able to get into it. If we do ping google.com, you see it has an internet connectivity. So everything looks good. You can even check sudo yum update -y. If there is something to update, it is going to update it as well. So let's check that also. Fail to set. Oh, that's okay because there's nothing, no packages work for update. That is fine. Even if you want to check it, you can do it on your own. So we are not concerned about it. Let's go back and see what is the next thing that we want to do. In our guide, it says now we have to create an EC2 Linux instance within my VPC and within my private subnet. In this case, we are going to disable the auto assign public IP. We will name it my private server and we are going to create a security group which allows SSH on port 22 to IP address for public subnet. We want that this instance which has been launched within private subnet, it should only be reachable as SSH from public subnet, from my applications, from my EC2 instances which are within public subnet. So we are just going to do auto assign IP public IP is disabled because we do not want any public IPs for this to be reached by internet. We are going to name it my private subnet. Okay, it is being launched, my private server. This is being launched in completely new availability zone. We are going to create another security group. And as I mentioned, the important point here to note is we are just allowing SSH from the public subnet machines. Okay, because our applications, our web application, let's say, are going to be launched on these EC2 instances within public subnet, and they should have access to your database machines, which are like your private server. We are going to create another key pair. Let's create it just so I should demo how this is done as well. So let's create another one. Create a new key pair, and let's give it some name, my Linux private key pair. Now this key pair, it is going to be stored in the public server, because you want to do SSH from the public server to private server. So the key pair is required to be copied within the public server. So that is the next thing that we are going to do. We are going to copy the key which we have used to log into my private server, needs to be copied to my public server. Okay, so let's try and do that. So we'll go, just a second, let me, yeah. Okay, so we go to the terminal. Here we are going to, there's nothing as such, so we are going to vi or create another, open a vi editor and mykeypair.pam file, and here we are going to copy the my Linux private key pair what we have downloaded. I have just opened it in a notepad and we are going to copy paste it here. So once you copy paste it, and we will have to change the permissions also, as you would know, it will throw an error otherwise because of the ownership. So let's do chmod 400 mykeypair.pam. So only owner has got access to use this PAM file, okay, which is a security mechanism provided by AWS while SSH. So SSH ec2-user @ we need to go and find the private IP. Please note there won't be any public IP for this private server, as you can see here. So we are just going to use the private server IP. So let's copy the private IP and we will go back and paste it within our terminal, and we will see if we are able to get into this private server or not from my public server. So -i mykeypair.pam file. Yes, and yes, we have been able to launch and get into this private server. Now let's test internet connectivity here. Do we have an internet connectivity or not? So we are just going to do ping www.google.com as we had done the last time. Okay, and you see we are not getting any packages. No packages are being returned. So that means we do not have an internet connectivity. So how to establish an internet connectivity? If you remember the diagram that we have created, we need some kind of a secretary or some kind of a mediator, which could be a NAT gateway or a NAT instance. Okay. So there are two ways. What we are going to try is through NAT gateway. NAT instance is something I have provided instructions here, and I leave it to you to try it yourself. So we'll try it through a NAT gateway, create NAT gateway and name it my NAT gateway in public subnet. So important, we are going to launch it within public subnet, because within public subnet, this NAT gateway will have internet connectivity, will have association to internet gateway, but it will be the only point that would allow connectivity to the private servers. So we are going to launch it within public subnet. So let's use my public subnet here, and it requires an elastic IP. So we can just allocate elastic IP address. This is going to get charged IP address. So we will, important to note, we will have to release it when we clean up everything. So let's name it my NAT gateway. Let's create a NAT gateway. It has been created, and it will require you to update the root table now. Now we will have to go to my main root table, because my private subnet is associated to my main root table, which is default. As you can see here, this is my private subnet. Okay. Now I want that this my private subnet should be able to connect to the internet, to the outside world, through this NAT gateway. Okay. Instead of my internet gateway directly, which is done in contrary to the public subnet. Here in private subnet, you want that the outside world should be reachable through NAT gateway. Okay, that is the purpose of NAT gateway. And now we are all set. We should be able to have an internet connection within my private server also. So let's get back to my private server and check. Please note it does take some time to reflect. So if you currently see, it is taking time. It is not still returning packages, but maybe after a minute or two, if we go back, if we keep on trying, there will be an internet connectivity. So as you can see, after a minute or something, there is an internet connectivity that we have now. So you can ping google.com. So just a little bit of time. But through this illustration, for the diagram that we had created last time, you can see what we have achieved so far. For the NAT instance, I leave it to you. Please do it as per your own convenience. You just have to create another EC2 instance of type NAT. If you just search AMI for NAT, and create a security group which allows HTTP and HTTPS. Important, disable source destination check. This is very important. So as soon as you are going to disable source destination check and added the route table the way we did it for NAT Gateway, everything should work fine for you. Now it's time to do a cleanup. Okay. We need to stop both instances. Important here is release elastic IP. This is mainly this is the main step which is usually forgotten. So let's firstly exit from both of these machines, both my private and public subnet servers, and thereafter we are going to terminate them. So we will go to instances and we are going to terminate both of them. So let's firstly terminate my private server. It is terminated. Now let's terminate my public server. It has been terminated as well. It will take some time, but meanwhile we can go back to VPC Dashboard, and within VPC Dashboard you can see now there are two VPCs, one by default, one we created, Subnet 3 by default, 2 that we created, route tables, one default, one that comes with VPC, the VPC I created, and one route table that we created explicitly. So firstly, let's go to my VPC, try to delete it. It will not be deleted because there are too many associations. So it asks us that network interface deletion is required and NAT gateways are associated, so I cannot delete it. So network interface is something which will get deleted automatically, but NAT gateway, it has to be deleted first. Okay, so we'll delete the NAT gateway. It is getting deleted. And network interface, something we don't care about, it will get deleted all by itself. Subnet associations or route table associations, this is something we can take a look at. As I mentioned, through 3 route tables, one that came, this is my route table which I explicitly created. Let's have this added the subnet associations. We are going to remove any associations. Okay, so associated subnet, let's delete it. So no associations as of now. And now you can delete this route table. So this route table should be deletable now. Rest everything are created by default. So we can just go and try again within my VPC and let's try to delete it. I believe everything should be able to get deleted now. NAT gateways, I believe it's still getting deleted. So let's go back and see if it has been deleted or not. Let's refresh it. It is deleted. We can try again to delete my VPC. Delete VPC. Okay, so it is going to delete all of these things. Most of the things that we want to delete will be deleted. Security gateways, internet gateways, subnet, everything has been deleted. So I believe we are good. We can again go and check within VPC Dashboard everything that we wanted. So one VPC which is by default, that's okay. Subnet 3 by default, per availability zone, route table 1, internet gateway 1, network ACL 1. Gateway it's still showing up, but we have already deleted it. It is going to take some time to get reflected, which is okay. But one important thing, elastic IPs. If you are not going to disassociate or release it, you are going to get charged. So very important, please release this elastic IP address, and as soon as you release it, it is not going to be there and you are not going to get charged. So that is all that I had to discuss in this video. Very important practical demonstration. I hope you did like this video. If you did, please like it, share it, comment, and please do subscribe to my channel. Thank you. Thanks for your time.